Welcome to the lecture Traveling Waves. In this lecture, we will discuss dispersion, refractive index, impedance, and energy flux of a traveling wave. So we studied that a traveling composite wave in free space, which is a superposition of different wavelengths or different k values for k, we know that k is equal to 2 pi by lambda, the wave number, change its shape when enters a medium with different properties, and this phenomenon is called dispersion. So the dispersive waves are sinusoidal waves for which the phase velocity v depends on the k values. That is, this phase velocity v varies with wavelength lambda or wave number k. That is, v of k is equal to omega of k divided by k. In other words, this frequency omega will be a function of k, or it will vary with k. When phase velocity is independent of the wavelength or wave number, or this frequency is independent of the wavelength or wave number, such waves are called non-dispersive waves. In that case, this will be a constant. This omega will be a constant and k will be a constant, so that omega by k will be a constant. Now, we will see what is the relation between refractive index and dispersion. We know that the velocity of light in vacuum is c is equal to 1 by root mu 0 epsilon 0, which is equal to substituting the values of this mu 0 and this epsilon 0. This is equal to 3 into 10 to the power 8 meter per second. So velocity of light in a medium is given by v is equal to 1 by mu epsilon, not mu 0 epsilon 0, but mu epsilon 0. Mu is the permeability of the medium and epsilon is the permittivity of the medium, where this mu is given by this mu 0 into mu r, and this epsilon is also given by epsilon 0 into epsilon r. This r corresponds to the relative, that means relative permeability and relative permittivity, and this mu 0 is the permeability of the air or vacuum, and this is again the permittivity of the vacuum. So this can be written like this. This 1 by root mu 0 epsilon 0 can be replaced by c, so that this can be written like this: c by root of this mu r, this epsilon r. So the refractive index of a medium in terms of velocity of light is defined like this: n is equal to velocity of light in vacuum divided by velocity of light in medium, that is c by v. So replacing their expressions, that is c is 1 by root mu 0 epsilon 0 and this v is 1 by root mu 0 mu r epsilon 0 epsilon r, or this is c that divided by this v, the velocity of light in a medium v is c by root of mu r epsilon r. So substituting here, this will be the c get cancelled and this goes to the numerator, so that this becomes n equal to root of mu r epsilon r. That is phase velocity of light in vacuum divided by phase velocity of light in medium, that is c by v phase, that is phase velocity, is equal to root mu r epsilon r. Also, we can show that this lambda is equal to V by nu. This is a general relation for a wave. Lambda is equal to V by frequency, velocity by frequency, so that this V is replaced by C by n. This V is C by n. Velocity of a wave in any medium, velocity of light wave in any medium is C by n, so that this is C by n divided by this nu, that is the frequency. Now we can replace this C by V as lambda vacuum. We know that this C is the velocity of light in vacuum, this nu is the frequency of the light wave, so that the C by nu will be the wavelength in vacuum, so that this lambda can be lambda in a medium can be written like this, lambda vacuum divided by n. Similarly, k in a medium can be written like this. The k in general is omega by v, where v is the phase velocity. Here again, this phase velocity is replaced by c by n. This n goes to the numerator, so that it becomes n into omega by c, where this omega by c is written like this. We know that this omega is the angular frequency and c is the velocity of light in vacuum, so that this omega by c will be the value of k in vacuum, so that this k in a medium can be written like this, n into k in vacuum. Now we will introduce a new term, impedance. For a transverse traveling wave in a string, the phase velocity is given by root of T0 by rho 0. We have already studied this equation in our lab sessions. Root of T by rho or root of T0 by rho 0, where T0 is equilibrium tension on the string and rho 0 is linear mass density, that is mass by length. For a transverse wave in a string, the quantity defined as z is equal to root of rho 0 T0 is called characteristic impedance or simply impedance. So this is the impedance. Impedance is equal to root of rho 0 into T0, where rho 0 is this linear mass density and T0 is the equilibrium tension on the string. So this impedance determines the rate at which the energy is radiated onto the string by a driving force, that is from the source, at which rate the energy is radiated or transmitted is determined by this Z value or impedance value. Like in electric current. In electric current, the current is determined by, the intensity of current is determined by the resistance or impedance of the circuit, like that. Also, we can show that this Z is equal to rho 0 into T0, which is equal to T0 by V5. From these two equations, we can see that this is equal to T0 by V5. Now, what is the rate of energy radiated? That is the power or energy flux. Radiated output power can be written like this. This is equal to the transverse force into the transverse velocity. That is the force along this direction, along the transverse direction, the perpendicular direction, into velocity along that direction. Means velocity of oscillation of the point of the disturbing point, of the oscillating point at that point, so that the power will be this force into velocity. That is, power radiated P of t is equal to the transverse force Fx into the transverse velocity dou psi by dou t. For a traveling wave, this p of t is equal to fx into dou psi by dou t can be written like this, where this fx and dou psi by dou t are replaced by like this. This fx is z into this impedance z into dou psi by dou t, so that this can be written like this. And this p of t in terms of dou psi by dou z is obtained like this. This fx in terms of dou psi by dou z will be this one, minus t0 into dou psi by dou z. So into this dou psi by dou t will be this one, minus v phi into dou psi by dou z into t0. This t0 by t0, which is equal to 1, is added here for the simplicity of this derivation, so that this becomes this t0 into t0, that is t0 square, then again this t0 square is there, this minus t0 square, dou psi by dou z whole square divided by this v phi by t0. This v phi by t0 is z. So that this becomes 1 by z into minus t0 dou psi by dou z whole square. Now we can see how these relations, how this fx is obtained like this and like this, like z dou psi by dou t and minus t0 dou psi by dou z. This is the case. This is the wave function psi of zt. We know we have already studied in the last class a cos omega t minus kz. So that dou psi by dou z, this is the partial differentiation. So assuming z as the variable, all the other quantities as the constants, this becomes like this, ka into sin omega t minus kz. And again, dou psi by dou t becomes minus omega a sin omega t minus kz. So that this dou psi by dou z will be equal to, we can divide this with this one and will obtain this one. Since here the dividing these two LHS and RHS, this a get cancelled and this sine get cancelled, then the remaining term is k by omega, that is k by omega is 1 by omega by k, where omega by k is nothing but the velocity. That is why this relation. So you can divide these equations and obtain this one, dou psi by dou z is equal to minus 1 by v dou psi by dou t. Now this fx, the transverse force, is obtained like this. The transverse force is equal to minus t into sine theta, where theta is the angle from the horizontal, so that this fx equal to minus t into sine theta, which is equal to, which can be written like this, a cos theta by cos theta is added here, that is minus t cos theta sine theta by cos theta, so that this becomes, this t cos theta is the t0 and the sine theta by cos theta is tan theta, so that this becomes minus t0 tan theta, which is equal to minus t0 dou psi by dou z, where this dou psi by dou z is this one, minus 1 by v dou psi by dou t, so that this also can be written like this, t0 by v into dou psi by dou t, where this t0 by v is, we already seen that this t0 by v is equal to the impedance z, so this is equal to z into dou psi by dou t. That is why here we replace this fx can be replaced either like z dot I by dot t, this z dot I by dot t, or minus t0 dot I by dot minus t0 dot I by dot z. And this dot I by dot t here is replaced by this dot I by dot t is replaced by minus v phi into dot I by dot z minus v phi into dot I by dot z. From this equation, dot I by dot is equal to this minus v phi is taken to this left side, so that this becomes minus b phi into dot I by dot z. That is why these equations are like this. In that is, this power is obtained z into dot I by dot t whole square, or 1 by z into minus t0 dot I by dot z whole square. Here, this P of t represents the radiated power emitted at z is equal to 0 by the transmitter in the form of traveling waves, or by the source. It is equal to the amount of energy per unit traveling wave, unit time traveling in plus z direction. That is the amount of energy per unit time, that is the power traveling in z direction. Now we will study a few points regarding the sound intensity. We have studied sound waves are longitudinal waves. The intensity of sound, it is defined as the sound energy propagating through a unit area per unit time. We know that the energy per unit time is the power. So intensity of sound is the power by unit area. The power, the energy propagating through a unit area per unit time. So the unit is watt per meter square. Since the intensity of sound will be very small, a standard intensity is defined for the intensity of sound. The standard intensity of sound is I0 is equal to 10 to the power minus 12 watt per meter square. Average person's threshold audibility of sound. Threshold audibility means minimum intensity of sound that can be heard. Generally, this threshold audibility depends on the frequency of the sound. At 440 Hz, the threshold audibility is equal to 10 to the power minus 10 I0. That is, I threshold is equal to 10 to the power minus 22. This into 10 to the power minus 10 into 10 to the power minus 12 watt per meter square. That is 10 to the power minus 22 watt per meter square. Human ear has a huge dynamic range factor of 10 raised to 12 in intensity. That is, we can distinguish different intensity of sounds in a very huge range. That is from 100 I0 to 10 to the power minus 10 I0. Change in sound intensity is experienced in logarithmic manner and is expressed in the unit bell. That is the intensity of sound. We cannot detect, or we cannot say that the experience of the intensity of the sound will not be multiplied by 2 when the intensity is multiplied by 2. But when the intensity is increased by 10, we will experience that the intensity is multiplied by 2. That is meant by it is logarithmic manner. The change in sound intensity level is defined as L is equal to log I by I0, where this I0 is this one, and is minus 12 watt per meter square. The unit is bell. If this I is equal to 2 I0, then the level will be 2 bell. and generally it is expressed in decibel. Decibel means 1 by 10 bell. 10 bell is decibel. So that this is equal to, in the level in decibel is equal to 10 log I by I0, and the unit is decibel dB. Now the visible light intensity or luminous intensity. Standard intensity for visible light is candle, or in short CD. It is the brightness of an ordinary candle. It is defined as 20.3 milliwatt of visible light output power emitted in all directions. Thank you.